Hi, we are Group 2 and we're presenting on climate change and infectious diseases. The life cycles and transmission of infectious agents are directly linked to climate change. Some of the microbes talked about in this article are viruses, which is talked about as the avian influenza, bacteria, which includes diarrheal diseases such as cholera, and then also parasites, which can be seen as malaria. Some of the predictions for the consequences of climate change on infectious agents include induced range expansion in malaria due to climate change, malaria being more prevalent in higher altitudes and geographical locations, and an increase in temperature alters the risk of diseases.
Ecophysiology of host-pathogen interactions and the host-pathogen relationship. The relationship between a host and a pathogen are involved in diverse communities and can affect ecosystems in different ways based on their existing biodiversity. For instance, in polar regions, new diseases can create a harsh impact to the environment due to the low biodiversity in the area. And the effects of the temperature increase are that the deficits may outweigh the benefits of a warmer temperature when it comes to pathogen growth and development, in that warmer temperatures will result in decreased immunity for the host, and in some cases, faster replication for the host that will eventually lead to more disease in the long run. As for the benefits, in things such as gorgonian corals, warmer temperatures increase cellular and humoral defenses, which bring more resistance to pathogens. The metabolic theory of ecology involves using established relationships between traits of species like metabolism, temperature of the environment, and body size to find out how an organism will respond to a hypothetical pathogen. This theory can be applied to any environment. And the importance of MTE is that the metabolic theory of ecology is becoming increasingly important to our world today due to the rise in average global temperature due to global warming. With MTE, one of the main things that can be accomplished is that theories can be developed and predictions made about specific organisms' responses to a changing environment.
Due to global warming in oceans, mutualistic microbial communities, the coral reefs, are turning pathogenic due to a lack of production of antibiotic-producing bacteria. This is causing a rapid decline in coral reefs, specifically in the Caribbean area. The change in bacteria affects many other ecosystems and changes relationships between organisms that coexist. Changes in the environment, including an increase in disease, heavily changes the keystone species, and it creates a waterfall effect for all other species in the ecosystem. If the keystone species hosts change, which can increase disease for the species and decline the population of the keystone species, it will create ripples throughout the whole community as the keystone species is heavily relied on for many other species. Commensal microbes protect their host organism by applying protective defenses against any foreign pathogens in the immune system. Mutualistic microbes help their host while the host also helps them, typically providing a food source for the parasite. With climate change, pathogens could increase and change relationships between microbes and the host. This can eventually lead to an increase in disease and infection. Because everything in a community works like a machine, every part is necessary to keep homeostasis. When one part goes missing, that can ripple every other species that coexists. For example, when a host protective microbes goes extinct, the host is more prone to disease, which could eventually kill the host, which could also be another organism's food source.
In behavior, movement, and phenology of host and parasites. Phenology, the study of periodic events in biological life cycles and how these are influenced by seasonal and interannual variations. These changes can be noted to the monarch butterfly migration as well as vector life stage timing changes, which includes rapid transmission of disease and the timing of shedding of different organisms. Trends in climate change. Monarch migration, as well as a shift in different patterns of movement of birds, can be contributed to the warming bodies of water caused by global warming. These climate changes can increase tick frequency as well as stagings and timings of shedding. On the graph to the right, you can see that the climate change accelerates transmission cycles of disease as well as builds up thermal tolerance of pathogens.
Consequences for conservation and human health. Wildlife disease affects humans, like the indigenous people who rely on wildlife for food and cultural activities. Diarrheal diseases, such as cholera, have seen increase due to global warming and are linked to rainfall and warm temperatures. Some of the societal implications and the importance of forecasting and early warning programs. These are important because they allow the effects of climate change on infectious diseases to be seen quicker, which leads to better management of the effects of these diseases.
Outlook and future challenges. Mechanistic models and drivers. When we look at studies that involve how climate change affects pathogens, there are a few mechanistic factors involved, such as ecophysiology, precipitation, relative humidity, and extreme events. In these studies, models are used to show how pathogens react to climate change. Challenges. When we look at the study of how climate change affects pathogens, there are a few challenges to be solved. One is solving the detection of climate change in these studies. A solution to this problem will be, with the passing of time, new technologies can detect variability in physiological processes.